So, it was the summer of 2008. We were in the end stage of a production called Chronicles of Riddick, Assault on Dark Athena, for which I was the producer. Like many others, we were in a very bad position here. We had all levels running out of memory and shoppily moving forward, so performance was low. Now, when we looked through all the levels in this game, we saw that we had hundreds and hundreds of assets. And we didn't need to cut a lot, but we still had to touch basically everything in order for this to be optimized. Now, on texture side, we had smart solutions to reduce those. But for models, it was more difficult. We actually had to do manual labor there. So this was a very stressful situation for us, and we also were basically risking our release date at this stage. Now, one morning when I was sitting in my room, probably contemplating how to get about this, one of the programmers comes into the room, raised arms like this. I found 8 megs in the audio buffer, and we don't need that big. So we can cut 8 megs there, which is going to free up a lot of memory. Now, those 8 megs took us almost all the way, which allowed us to get all the levels done. And we didn't have to cut quality by removing models or reducing the big ones. That saved us months and months of work and probably even pushing the release date because of this problem. So my name is Rantaeskola. I'm a product expert for Simplygon, a Swedish company that works within 3D optimization. These are some of the titles that I worked on in the past. I wish there were more. Quite a few of those have been canceled. And these are some of the companies that I worked prior to joining Simplygon. So, for those who don't know, we consider ourselves, Simplygon, being the gold standard for 3D optimization in high-end video games. And in my line of work, I travel around the world, meeting studios pretty much everywhere. These are some. We talk about these problems. And on the top of basically every major developer's agenda today is optimizing and making an efficient asset pipeline. So, what's up with the title? Well, let's hop back 20 years in game development. This is how games started. I mean, this is how many smaller games start today as well. You have 2 programmers. They're sitting next to each other, they're coding, there's perhaps an artist as well. Now, when the build eventually breaks, the solution of fixing that build is not more than just slap in the face the guy next to you, guy, you broke the build, fix it. And 5 minutes later, it's fixed. But team sizes have grown over the years, and it's not as efficient to solve a problem. If a programmer breaks the build, I mean, then there might be 20 people that can't do anything because the latest build does not work. So, this is somewhere around like 2000. We became more careful in how we coded. We put coding standards into place so that it's harder to break the code, and also easier to maintain it. But still, we had this one guy, the lead programmer or the build engineer, that was the guy that you went into and said, like, we need a new build. And he started the build, and then he put that up on some file server somewhere so you could distribute it to all the machines. This is not very efficient either. So, somewhere around 2003, 2005, we started looking at, we need to set up build systems. We need to be able to easily build a build. We can't rely on one person. We need to be able to distribute it to any console fast because it just takes too much time. Now, this is what we've done to coding over the last 20 years. The asset pipeline has not received the same amount of attention. And that's probably because assets are not as likely to cause failures and broken builds. as code is. But assets affect performance hugely. And building a game, it's not just about keeping the game running. It's about keeping the game running in a representative state. So what is a representative state? Well, the earlier you can have the game running with a correct representation of memory and performance, the less risk you have in the end phase of the game. So, let's go into a little bit of background regarding the asset pipeline. Why do we even optimize? Now, some of you here are probably even a lot better than me at this, but I'm going to give you a high level for the ones that don't know, why do we optimize 3D content at all? And I'm not going to be super technical. I'm just going to give you kind of a few bullet points here. Back in the days, like 20 years ago, we were optimizing 3D assets because we could not push that many polygons out on the screen. Polygons were expensive. A character was like 100 polygons, for example. Nowadays, that's not the main reason why we optimize. One of the reasons we do optimize is to reduce overshading. And this applies to pretty much all the hardware that's out there today. Basically, the GPU is not structured in a way that it's efficient to render small polygons. And the smaller the polygon, the more expensive it's going to be to render each pixel. So we're actually optimizing models to get larger polygons. And here is an example of this. So this video shows a highly tessellated character on the right-hand side and a low tessellation character on the other side. The highly tessellated one is very expensive to render. The red pixels are the most expensive ones, whereas the blue are the cheap ones. And this is basically because small polygons are more expensive to render. Another thing which is also this is kind of new to this generation, it's the fact that we do have a lot of memory at our disposal, at a PC, or for example at a 360 or Xbox One and a PS4 we have 8 gigs, but we cannot use 8 gigabytes of memory every frame to render. So there are some math on this, and in optimal situations you can do somewhere around 150 to 200 gigabytes of data per second, which in reality is more like 100 gigabytes. But if you would render a game at 60 FPS, that means that you can only transfer 1.5 gigabytes of memory every frame. And even if you're doing VR, you're down to about 1 gig. So even if you have 8 gigs, you got to be smart with what you send to the screen when you're rendering. Draw calls is probably the #1 reason why people look at optimization today, because that's where the huge bottleneck is. Basically, every time you render a new material or a new object, there's a boot up cost. So you want to batch things together and be smart in how you optimize content. So for example, this case, let's say that we're building with modular content. This might consume like 10 draw calls, just this asset. But if we could merge that into one object with one atlas, we have only one draw call. And draw call limitation depends a lot on hardware and engine implementation, but we're not talking of millions of draw calls per frame, perhaps 1,000 to 5,000, depending on frame rate and other things. Character-driven games and animation-driven games overall, animation cost is a significant portion of the rendering cost. Now, we need to be smart in not calculating animations that are not going to be visible. So when a character is far away, perhaps no point in animating the fingers. So every time we send a vertex to be rendered, it's going to have to be transformed into the world. It's very cheap, but if you do that 1,000,000 times, it starts to becoming a huge problem. So you want to reduce the amount of vertex transformations per frame. And finally, reducing overdraw. So if you're drawing, every time you draw a pixel, you have to apply shaders, and the more times you overdraw, the more costly each pixel is going to be. So these are some of the reasons, there are more, but I chose these, to why we are actually optimizing content, even today, with huge capacities, great CPUs, great GPUs. We still have to optimize if we want to maximize the output for the game. So where are we today? Before, when I was preparing this speech, I was talking around to a lot of my peers, people that I worked with, people that are building large games today, smaller games, just to kind of get an idea of where the problems are. And what I get is that asset complexity is increasing a lot. Characters, it's not uncommon today to have a character at 300,000-400,000 polygons being rendered. We have more complex shaders, we have larger textures. There's a lot of information for each asset. And what people are saying to me is that the more complex an asset is, the more time it takes to optimize it. Now, we are at a point, I don't think that team sizes can grow much larger than they are today. I hear of games that are peaking at 800 people. I hear 300-400 people. Personally, I was a producer of 100-person people, and I felt or 100-person team, that was just painful to manage. It's not very efficient once you go above 100, but you have to do that with the amount of work being done. Secondly, we can't really ask for more money of our players when we're talking about the big games. So we have to be smart in how we use our time and money, like him. He's probably very smart with the time he's got left. And since I'm focused on 3D asset production, how much is that of a game budget? And once again, I asked quite a few people out there and got these numbers. So of a AAA kind of game, asset production stands for 30 to 70% of the budget. Now actually this is just two buckets. I had a lot of answers around 30 to 40 and a lot around 60 to 70. 30 to 40 were in-house engines, 60 to 70 was people using off-the-shelf engines. With that amount of money put into a part of the game, whatever we can automate will be greatly beneficial and increase efficiency. So I collected some stats. And the stats I collected was focused on how much time do you spend on optimizing content in your game. Here's the first one. This is actually from a presentation at GDC where my co-presenter shared these stats. So this is a medium-sized AAA game. They did some calculations, seeing that they have about 1,500 environment models, for which of each takes about 2 hours to optimize. And they have 50 characters, which you have to spend about a day to do optimization for. So the total time, if you sum this up, is roughly 25 man-months, 26 man-months of optimization work. Now, a large, really large AAA game that I talked to, they shared these figures with me. They said that they have about 5,000 assets in the game. Actually, quite a lot. It was almost 6,000. But I wanted to make it like 5,000. He said pretty much any larger AAA game has 5,000 assets at least. Now, one figure he had counted over the years was how many times is an asset touched per throughout the production. And his figure was 3.6 iterations on each asset. And then I added a crude estimate saying, like, let's say you do 1 hour optimization every time you do an iteration on an asset. So if we sum that up, it means that in a game of that size, there's roughly 110 man-months of optimization work. That game also shared this with me, that his estimate that was around 30% of an artist's time is spent on optimizing content. On our back end, we can see how many times people run our software. This is from a number of AAA games during 90-day period. And on average, this means that we run about 100 optimizations per day. If we do some crude math on that, it ends up to being about 40 man-months in a 2-year project. So my summary of this simple little stats gathering is that in a AAA project, automating parts of the asset pipeline can cut out 25 to 100 man-months of optimization work. It depends on the size of the project, of course. So that brings me to the subline here, a modern asset pipeline. So what is this? Well, this is what I see as being on the top of the radar on most major developers today. It looks something like this. This is my thought of that. There are different versions, but I'll just leave you 10 seconds to look at this. And I'll take you through what my thinking here is. So, let's say that we have an artist that has built this asset. Traditionally, what he would do is build a couple of versions of that asset and check that into the repository. Now, in reality, what he would do is check in the high-res asset and then wait a while before it's approved to do all the optimized versions, which means that we're going to run the game with a faulty memory footprint and a faulty performance indication. The modern solution is that we just check the high-res asset in. Behind the scene, we have an optimizer ninja who sees that there is a new asset that's just come in, and I know exactly what to do with this asset, and spits out different versions of this asset. It might be we have a low-end PC version, we have a LOD chain, we have a mobile version, we have different versions of this asset. Then when we're building the game, the build server kicks in and says, okay, I'm going to build a console version, I'm going to build a PC version, and a mobile version. It would know which asset to grab and distribute into the different builds. Now, the important aspect of this, which I'll get to more later, is the controls. We need to have controls on this that allows us to tweak and tune, because this will give us power towards the end of a project. Now, you're not going to get this every asset to be perfect. So we need some way of capturing assets that comes through and is not looking as we would like them to. So that's the fix list, and I'll get more into detail what ends up on that. So let's look at the components here. The optimizer ninja here reacts to new or changed assets. It should automatically optimize an asset by class. So characters get one set of optimizations, house gets another. And it continuously keeps the optimized cache in sync with the source data. And it should also have a possibility to automatically fix broken assets. So what are the optimizations controls? Well, of course, you have to be able to tweak the settings for each asset by class and platform. Every time you tweak something, it should automatically generate new versions of this asset. But we also need a way for different types of assets to pass through this untouched. The build server only needs to know which version of asset to use for which platform. But the problematic assets, that's where the fixed list kicks in. So I heard a clever solution by Telltale, who gave a presentation with us at GDC this year. What they've done is that they've implemented a paintball mechanic in their game. So basically, they're optimizing everything automatically, but as soon as they see something in the game that doesn't look good enough, you can just mark that asset as, yeah, this needs to be fixed. So it ends up on the fixed list, and then, as I said, the optimizer ninja should have some way of saying, okay, let's not optimize this asset so hard. Let's give it a little more resolution, for example. Then it might be that this asset ends up on the fixed list again. Well, then we might have to get our hands dirty and actually fix it manually. So, what are the benefits of us setting up a solution like this? The first thing is that manual optimization of content is not very efficient. Because when you are modeling assets, you're sitting very close to it. And let's say that we're building a version of an asset that's going to be 20 meters away. If we do that manually, we're going to sit and look at it like this. And this perhaps looks ugly, or probably does in an artist's eye. But if it's visible at this distance, we're probably fixing things that are never going to be seen in the game. And we're spending a lot of time there. A computer doesn't care. This allows us to utilize the capacity of different platforms. Without an automatic solutions, we're going to be restricted by the bandwidth of the team, which means that, well, if we have a low-end PC spec that we're going to deliver the game for, we're going to build all content for that. And then finally, when we're doing an iPhone version or an iPad version of the game, we'll probably have to rebuild all the content specifically for that platform. With an automatic solution that optimizes content, we'll at least get a good start on each of these platforms rapidly. Now this is actually the biggest benefit. The final footprint immediately. And this ties into my story that I started with. The thing is that if you are running the game or developing the game as most people do, people check in an asset, let's say the first character that is being built. It's very unlikely that it will look the same way when the game is being shipped. So you're not going to do a lot of optimization work for this asset. And this is going to happen for a lot of assets throughout the game. And you're pushing basically, yeah, let's do the optimization at the end. This leads to a faulty impression of how much memory you have at your disposal, because you don't know how much content is coming in. Secondly, your game will run choppily because, well, we do not have LODs in yet. Yeah, but it's going to work when everything that comes in. And when everything comes in, you see, oh shit, we're actually really bad shape, which adds risk to the end of the project, which leads to crunch. Now, let's say that we, at the end stage of a project, realize, well, actually, we have a lot of memory at our disposal, but we didn't know that we were going to have these large view distances. Now, at this point, you're perhaps not going to go through all assets and build another LOD, but With an automatic solution behind the scene, you're just going to tell, hey, we need a new load, and it will be spit out. It's also a tool that allows you to tweak and tune between memory and performance. Because it's basically, we're sacking memory to gain performance, or vice versa. So at the latest stage of a project, if we see that we're out of memory, saying, let's try what happens if we cut 5% of all the polygons in the game. Let's see what happens. You might free up a couple of megs, which takes you under the memory, or nowadays probably tens of megs, which takes you under the memory budget, and you're done. You can't do those kind of tests manually. It would take too long time. You just have to make a decision. We're going to do that. Drawbacks. Well, the first drawback I see, I'm not going to tell you that this is all peachy. There's a lot of different drawbacks. But the biggest one is that there is an initial effort that needs to be done to start this. And this effort needs to be done very early in the project. Because you don't want to do it when you're finalizing, because you don't have time. And the earlier you set a pipeline up like this, the more benefit you can draw from it. So, but the problem is that you're making a game, and you want to try to make as much of the fun stuff early on as possible, and then fix the boring stuff at the end. Setting up an automatic solution early on will gain you a lot if you're making a big game, and even for smaller games, actually. Well, it is, I don't think it's possible to get every asset to perfect. So one has to set a boundary saying, like, let's aim for 90% of the assets being done automatically. The other 10% we fix manually. We've taken away 90% of the work. That's good. So here are a few strong cases that I feel would benefit, or benefits a lot from a solution like this. So here we have a game with a lot of different assets, Final Fantasy XIV, large view distances, free roaming. It's just going to be a no-brainer to set something up like this. This kind of game where you can fly, you can go into cities, GTA 5, you can look at the world in so many different viewing angles. It's basically impossible to build it without doing something automatically behind the scenes. Our Polish friends, Dying Light, I use that as an example. You have a lot of characters. You have to do a lot of optimization to be able to push as many characters out as possible. When you're building with modular content, this is also, I mean, most of the game engines today are built up using Lego pieces, basically. Automatically merging these into a cheaper version will gain you a lot of draw calls and probably also memory. If you're a studio that are building a lot of iPhone games using, for example, porting, or it's a good start to just have something that automatically optimizes everything to get you a starting point for the iPhone game. So, what I presented here is a summary of why I think this is something worth doing. Setting up an automatic asset pipeline, optimization pipeline, it reduces manual reviewing, which will save you a lot of time. It utilizes platform capacity in a better way. You get the final footprint immediately. It's easier to add new loads at the late stages of the project. And you got a performance tweaking solution in. It does take time initially to set this up, and you're not going to be able to reach perfect. So, this is what I presented. as a solution to make it simpler in the end of a project. Any questions?
Do we have questions? Oh, yeah, there is one.
Hello. I have one question because as far as I understand the whole topic of optimizing assets, to me the division should be made between two things. The optimization of the asset right after it's created in a given software like 3D Max or whatever, so we optimize it prior to importing it to any engine because we can do this. We can like foresee certain problems even before we test the asset within the engine. And the second thing is optimizing the asset within the engine, like when we see how it works in a game with the other assets within the given scripting and stuff. So do I understand correctly that this optimization ninja you're referring to is some kind of a software or a tool that acts on, that we can use on both those stages or only in one of those stages?
I think you can set, it depends on how you construct a build pipeline. You could use it for both stages. I mean, if you can have it to reduce, let's say that we don't care of how many polygons, we don't set a budget of our high reses. And then we make a first pass of just reducing high reses to a certain number of polygons before it goes into the engine. And then we're also generating the optimized content for the engine for different platforms. I'm not separating these two. I see it as the same problem. It's just getting content down to a certain size that you utilize the platform capacity in the best way.
Samuel, I think that's all. Thank you very much for this speech.